Θα περάσουμε τώρα στην επόμενη συνεδρίαση, στην επόμενη ομιλία, η οποία είναι από την Glynis Jones, την Amy Bogart, τον Mike Charles, την Dragana Filipovic και τον Vibke Kirlais. Η κυρία Glynis Jones στην οθόνη.
Right, when I first came across this unusual wheat, I'm just going to make a note of the time. Next slide, Alex, please. They started off at Rostumba in northern Greece, where there was a large storeroom complex which was destroyed by fire, thus preserving the grain. You can see on the right there, the grain in the pots. It must have been destroyed immediately after harvest because there's a lot of grain there. Next slide, please. The grain looks like this. It was stored in spikelette form and it was very well preserved. And the grains and the spikelette bases could easily be identified to species. So you've got dicoccum grains there on the left and monococcum spikelette bases on the right. Next slide, please. But in one corner of the room, not the room I just showed you, it was another room, we found a new type of gloom wheat that we hadn't seen before. Here are the spikelette bases. This is what they look like. And we didn't know what it was. It didn't seem to be any of the usual species like monococcum, dicoccum, or spelter. Next slide, please. So we compared these spikelette bases to modern examples of a whole range of wheats, but in particular to Triticum dicoccum and to Triticum timofeevi. And you'll see dicoccum there at the top. I would point to the features I was going to do, but I can't because obviously I'm not sharing the screen. But you'll notice that the scar, the attachment scar for the next internode, yes, and if you look at it, point to it on the new gloom wheat, it's very round and it's quite different to the dicoccum one at the top, but very similar to the timofeevi. Well done, Alex. And there are also various prominent veins on the glooms, which are present there, yes. And on the other side, Alex, not that one, next one, there, good. And again, it matches timofeevi much better, basically, than it does dicoccum. Next slide, please. There was a lot of interest. We presented this work in 2020 in publication, but we'd also taken spikelette forks to various meetings of archaeobotanists, particularly the IWGP, which is the International Work Group of Paleoethnobotany, and showed it to a lot of people. And we found an explosion of interest, really, in what this new type was. And people from all over Europe started sending us specimens that they'd found at their sites, which looked very similar, asking us if it was the same thing, or maybe they'd found stuff earlier which they thought might be an unusual form of dicoccum. And, you know, it spread. And when I say it spread, as you can see, this map shows the finds that we now know of this new type of wheat, which we think may be timofeevi. And it spread across Europe and Anatolia. So it's finds in the archaeological finds, most of the Bronze Age, are very widespread. Sometimes it's grown, it seems to have been grown as a pure crop. At other times it's mixed with other species and may have been grown as a mixed crop with other wheat species. But I think it's clear from this map that whatever it is, it was widely cultivated in the distant past. But at this point, in 2020, and until very recently, in fact, its exact identity and its origin is still uncertain, shall we say. And then, next slide, please. And then there's a bit of a breakthrough in 2020. We submitted both grains from Çatalhöyük in Turkey and spikelets bases from Poland to DNA analyses with colleagues at the University of Manchester. And they found the G genome in both specimens. Now, the G genome, AAGG, is specific to the Timofevi group, and as opposed to the Dicoccoides group, which is, or Dicoccum group, which is AABB. So this was confirmation of what we'd thought from the shapes of the spikelet bases, that it is in fact Timofevis. This was confirmation. In the meantime, Marianne Köhler-Schneider had also published criteria for distinguishing the grain. Now, the grain on the right, the Çatalhöyük samples are particularly interesting because this was a pure crop. It wasn't a mixture. The material from Poland was mixed. But it only contained the G genome and no B. So this was, very strong evidence from the group. Right, looking at the Çatalhöyük material a bit more closely, at the top there you see you have spikelet bases. These are modern Emma spikelet bases, in fact. But on the left you have a wild species, and you can see the attachment scar for the next internode is very smooth, it's very clear, and you can actually see the vascular bundles. Whereas the one on the right is from a cultivated crop where the rachis doesn't break up so neatly. And you can see it's a rough scar with a bit of protruding rachis still in place. Now, these are the typical types for wild and cultivated wheats, but you get a lot of, you get both types in cultivated crops, you get both types in wild crops, but it's the percentages that vary. So if you look at the white bar, the white part of the bar at the bottom indicates the number of smooth scars that are characteristic of wild species, and you're looking at early, middle, and late Neolithic samples, and the smooth scars are declining through time. So at Çatalhöyük, there seems to be a progression towards more cultivated forms. The shading at the top, the stripes, are protruding scars where you can actually get a bit of rachis still attached, and you see they're increasing through time. And the bands in the middle are rough scars. So the rough scars and the protruding scars increase through time, which shows that it's becoming more and more domesticated as time goes by. So this is showing that there, at least, the evolution of the wheat seems to be continuing. It's been cultivated for some time by now, because this is not a particularly early Neolithic site, but the evolution is still. Next slide, please. Right, Çatalhöyük again, this time looking at the grain and geometric morphometrics. And we're getting the same story here. The diagram at the top left, you have on the extreme left of the diagram, you have the shapes of modern, it's plotting the shapes of modern species, and Dicoccum and Monococcum are on the left, and there's archaeological Emma, again from Çatalhöyük, in amongst the same group. But then to the right of that upper diagram, you have on the bottom, the green cross is Triticum timofevi, and near the top, a bit further on, you get Triticum araraticum, it's Tara. And the archaeological samples are plotting in between them. So again, further confirmation that this indeed is an AAGG species. And the archaeological material is closer to Timofevi, but it's not quite the same. And in the lower diagram, you can see again the progression from early Neolithic to mid-Neolithic to late Neolithic. It's becoming more domesticated with time. So domestication still seems to be in process in central Anatolia. Next slide, please. There's also been some recent work on modern genetics of primarily wild species from the Timothy group. So on the left, you have a tree which shows Dicoccum at the bottom, or Dicocoides rather, the wild version of Dicoccum is at the bottom. And at the top, you have all the AAGG weeds. So you can see there are two clusters there, the green and the pink. And they're wild species, and they're forming two different lineages, with Timothy being the blue that's situated in the middle of that diagram. And these map out onto the map you see on the right-hand side there. The Timothy, Araraticum, which is the wild progenitor of Timothy, is spread across the northern distribution, so the pink and the green spots, and it shares a distribution with Dicocoides, which is much more widespread. It spreads into the southern Levant. So we have these two separate lineages. And as you'll see, Georgia, which is the place where Timothy was grown until recent times, is outside this range. So we have a bit of a problem. We're finding this gloom wheat, which we've identified as part of the Timothy group, and it's completely separate from the Georgian Timothy. Araraticum, the wild progenitor, doesn't grow in Georgia, and it's been thought for a long time that it was an endemic species to Georgia and was of little relevance to the early evolution and domestication of wheats. But that's proving to be not the case. So if we can move to the next slide, please. So we've come a long way since 2000, when we first started seeing this wheat. And what we know about it now that we didn't know then is that it was a cultivated member of the Triticum timothy group. It was domesticated in Southwest Asia from Triticum araraticum in the Neolithic period. And it was widely cultivated across Anatolia and across Europe for about 7,000 years. It's not a minor species. And it was still in the process of domestication while in central Anatolia. So it's becoming a much more important aspect of early Eurasian cultivation than was previously thought. And this is the story so far. What we still have to find out is its precise location and the extent of its origins. And we still don't know its relationship to the Triticum timothy of Western Georgia. Is the Timothy of Western Georgia a relic crop? It's a direct descendant of the early domestication in the Neolithic in that northern part of the distribution, or is it a completely separate domestication? We don't know the answer to these questions, but we are hopeful now with the identification of these two different lineages that one day it may be possible to answer these questions too. Thank you.
Λόγω της καθυστέρησης. Glenis, thank you very much for this presentation, which was very, very interesting, very revealing. So you would say that the process of domestication is on in Çatalhöyük for years and years.
Yes, that's very interesting. It's very interesting from an archaeological point of view, because there's a big debate, as you know, about whether domestication was a gradual process that happened in many areas, it was widespread, or whether it was a sudden development in one particular location, which is normally considered to be the Kahramanmaraş area in southeast Turkey. And this, at least, for this particular species, it's showing that the domestication process, we don't know where it began. It could be in southeast Turkey, but it could be further east. But certainly, seems to be a protracted process. It was taking a long time because it wasn't even domesticated. By the time that change that I showed you that's happening at Chatelhuyck is long after Emma, that is Dicoccum and Monococcum, were completely domesticated. There were very few of those smooth scarred types. So it's got implications really for our understanding of the origins of agriculture and how it occurred.
Okay, thank you very much. Thank you very much for this very interesting presentation. Τώρα, έχουμε καθυστερήσει πάρα πολύ στο πρόγραμμα και η πρόταση είναι να κάνουμε διάλειμμα. Φαντάζομαι ότι όλοι το χρειάζεστε, γιατί είμαστε περίπου... Ζητούμε συγγνώμη από τους ομιλητές που δεν θα γίνουν ερωτήσεις. Ίσως κάποια στιγμή μετά, σε κάποια άλλη φάση, να μπορεί να γίνουν, αν στον καφέ. Ο καφές είναι η καλύτερη λύση. Λοιπόν, σας ευχαριστώ πολύ για την προσοχή σας.
Ευχαριστούμε πολύ, Γκλίνης.
Yeah, I should go and get tea.
Yes, okay. Thanks.